Yes, the old open box volume problem. You will see this in every calculus class. A manufacturer wants to create an open box by cutting out squares of size x from each corner of a rectangular piece of cardboard measuring 8 by 10. So, there's my cardboard. This is me cutting out next, cutting out next, cutting out next, cutting out next. X is everywhere. X is everywhere. Now I know that one of these sides is 10 and one of these sides is 8, which means after I cut things out, you're going to be 10 minus x, so 10 minus 2x, and you're going to be 8 minus x, so 8 minus 2x. When I take these sides and fold them up, that gives me a box with an open top, right? Where the height is going to be x, the width is going to be 8 minus 2x, and the length is going to be 10 minus 2x. So this is where the fun begins. My job, after cutting the squares, the sides of the box will be folded up to form the walls. Yeah, I kind of got that. What size x squared should be to maximize the volume of the box. So this is where it gets tricky. The volume of the box is going to be x times 10 minus 2x times 8 minus 2x. Okay, so let's multiply stuff out. The volume is going to be 10x minus 2x squared times 8 minus 2x. Let's FOIL stuff out. 80x minus 20x squared minus 16x squared plus 4x to the third. And that's my volume formula. Now what I need to do is I need to take that volume formula and take the derivative of it. That's going to help me find maximum or minimum values. Okay, so the derivative, actually, you know what, let me clean this up a little bit. Let me put it in order, put it all together. That would probably be a smarter idea. 4x to the third minus 36x squared plus 80x. Okay, and I got that negative 36 by combining these guys right here. Now I'll take the derivative. When I take the derivative, that gives me 12x squared minus 72x plus 8. Set it equal to 0 to get me critical points. And what I'm also going to do while I set it equal to 0 is factor out a 4. 3x squared minus 18x plus 20. Now, the frustrating things about these types of problems and what we're left over here is you can't factor that. It's a mess. So we're going to use our dear friend, the quadratic formula. I'll call you A, I'll call you B, I'll call you C. X equals negative B plus or minus square root B squared minus 4AC all over 2A. And we'll plug in our friends. Negative 18 plus or minus, the square root of negative 18 squared minus 4 times A, which is 3, times C, which is 20, all over 2A, which is 2 times 3. All right, so the double negative 18, 18, plus or minus 18 squared is 324. Took me a minute there. Negative 4 times 3 is 12 times 20 is 240, but the negative version of it, all over, that'll be 6. This guy simplifies out to 84, all over 6. You can pull out a 4, which means you can pull out a 2, so 18 plus or minus 2. If you get rid of the 4 in there, you're left with, oh, no way, my favorite number, 21, all over 6. Now, I'm going to quick run to a calculator and type out what this guy is. Oh, by the way, no, I won't. 9 plus or minus the square root of 21 all over 3, because I can simplify all those even numbers. Now I'm going to go off to the side and see what I get. All right, so I got x equals, give or take, 4.53 and 1.47. One of these numbers can't make sense, and it's u. U can't make sense because if I were to say, all right, yeah, let's cut out 4.53 out of this thing, you would have 8 minus like 9, which means you would have negative box. That doesn't make sense. So our only feasible option is that 1.47. So that's the only guy we're going to be able to get. Tricky stuff. Quadratic formula is never fun, but you need to know how to use it, so this is us using it. Happy times.